All right. As I mentioned yesterday, we're going to take a look at the problems that law signs can present. What we're going to do today is just try and determine how many answers there could be. And then on Monday, we're going to actually go find all the answers. Some of them will only have one answer, so that'll be pretty easy. The ones that don't have any answers, even easier. The ones that have two answers can be somewhat complicated. But as it says here, law signs can sometimes cause problems because sign is positive in which two quadrants? 1 and 2. And if you think, again, this is what we talked about yesterday, if you think about quadrants 1 and 2, every single angle that's in there could possibly be the angle of a triangle. For example, 35 degrees is in there, or 155 degrees. They're all in there and could be angles of a triangle. And that's why sometimes we have a problem with that, because sign is positive in both of those quadrants. So if you're given an angle and two sides, so basically if you get the law of sine set up and another side, that's what the key is. So this is basically what this is saying, is if you get the law of sine set up, you get a pair and one more side, that's when you have to look. Okay? Obviously, if I give you two angles and the pair, you don't have to worry about it. Okay? That might be worth repeating. If I give you two angles, and obviously that side that makes a pair, there can't possibly be two answers, because if I give you two angles, isn't the third angle pretty well set? If I give you two of them, the third has no option. Okay? So here we go. Situation 1. Let's say, basically, you could look at it this way. I could tell you angle A is 120, side A would be 8, and side B then I could tell you is 10. Do you agree with that? That's one way I could give this to you. So do we technically have a pair? We've got angle A and we've got side A over there. The problem here, so this again, this situation is if I give you an obtuse angle, and obtuse of course means if it's more than 90 and less than 180. So I gave you a 120 degree angle. Notice what I gave you across though, I gave you 8. Do you see how this side is way too big? Look at it that way. That side's too big. What these dotted lines are is basically pretend if I could swing this. If I swung it out that way, that right there would still be approximately 8, right? Or I could swing it back the other way. Is that ever going to form a triangle? Because 8's not long enough, is it? It just is never going to make it. Because let's face it, across from the obtuse angle better be the biggest side of the triangle, correct? Because how many obtuse angles can you have in a triangle? No. 1. And so if that's not the biggest side over there, are you going to get any triangles out of this? No. Is law signs going to work? Oh, you could set it up, you could try, but it's going to give you an error. Now, what if, based on the information you have so far, that one is the biggest? Does that have a shot of forming a triangle? Yes. And look at how that side could swing. So this is the side right here that we're going to try and swing that way, swing back with this way. You could swing it all the way around. Is that ever going to form a different triangle than the one you have right there? Does it ever form another one? No, that's it, right? I mean, that's the only way that could happen. And so basically, if this one on the left happens, that's just flat out not going to happen. There are no solutions to that problem. You could try setting up law signs and not going to work. This one over here, you're only going to have one solution because it only forms one possible triangle. There isn't a second option. Okay. So obtuse are actually some of the ones you're going to want to get because they're pretty straightforward. Okay. But you remember in law of signs, I always told you to go for the smallest angle. And those are the ones that cause problems. Okay. So is everybody good so far with obtuse? Please don't forget this is an option. Some people do when they get to the homework. They're like, what do you do if it's obtuse? I'm like, look back at situation 1. Okay, because situation 2 is going to take a while. And I'm going to try and get this so you can understand it. Basically, this segment right here is often referred to B sine of A because it forms a right angle. The reason that's B sine of A, I could explain that to you. Obviously, this is side B then, right? And this over here is side A. So if I wanted to get basically sine of that, do you agree that sine of angle A would be, in this case, A over B, if I had to write it that way? So all they did is they just multiplied the B up to here. So do you agree B sine of A equals that other side? Here's what I would suggest you do. You know that we're doing law of sines, right? So you're going to get a pair, right? So what I would think of as take sine of the angle I'm giving you and take the side that's not part of the pair. And do it that way. If those two actually come out to be exactly equal, you are going to have a right triangle. Is there any way I can swing this side to make another triangle out of that? No, that's the only place it hits. That's it. And so that's why you will have one solution, and you know for sure it will be a right triangle. So I'll repeat it again. Take the sine of the angle you're given and take it times the non-pair side. That will tell you how long that one has to be. And okay, so get sine of the angle that you're given and take it times the non-pair side. Remember my word, the pair? Take it times the one that's not part of the pair. And that'll tell you how long that side has to be to form a right triangle. If you would like, there is an example that I have put in there for you. Not all these triangles that we're going to look at are 30, 60, 90, but for example, had I told you 30 degrees, and so let's say I told you measure of angle A is 30, side A is 3, and side B is 6. If I told you that, can you look up here and tell which one's the non-pair side? Yeah, you can tell that, can't you? You don't even have to draw a picture if you don't want to. Obviously, 30 goes here. What number would have to go over here then? 3, and then here is 6. So what you would do is take sine of 30 and take it times 6. The question is, does that actually equal 3? In this case, does that work out? Yeah. Now, is every single triangle I'm going to give you a 30, 60, 90, a nice one like this one, though? No. But if that's the case, this actually is true, right? So how many answers is this problem going to have? It's going to have 1. And we already know what type of triangle it is. It happens to be a right triangle. So if those two ever end up equaling like that, it's a right triangle. You know you've only got 1. And let's face it, at that point we know that's a right. We know that's 60. And we can figure that one out pretty quick too, can't we? We got that thing solved in a hurry. But that's only if it's a 30, 60, 90 because you got that cheat sheet. All right? Does everybody know how to find that distance? Because it's going to be really important. Do you think you know how to find it if I just gave you more information? Well, let's try another example then, because if we can't go on until you can find that for me. So try another one. Angle A is 40 degrees. I'm going to tell you side B is 10. What I want you to do is go find how long that side would have to be. Because you know this is 10, you know this is 40, agreed? How long would that side right there have to be for this to be a right triangle? Okay, do you have it? Let's give everybody a chance. Because that pretty much is SOHCAHTOA, what you're doing now, really, is what it ends up being, if you want to look at it that way. I just made this up, so there's no guarantee this will be a nice number. We'll round to the tenths then, just so you get an idea. So what do you have to do? Well, you take 10 times the sine of 40 degrees. And what does that tell you? So if this is 6.4 right there, guess what? How many answers does this have? It has 1, and we already know it's a right triangle. Guaranteed. If it's something other than 6.4, that's when we're going to have a problem. For example, let's see if you can figure it out without looking at the notes. What if this was, say, not 6.4, but 3? Remember, that distance right there is guaranteed to be 6.4 in this problem, right? What if it's only 3? It's not a right triangle. Is that ever going to swing and actually make a triangle? How many answers is that one going to have then? None. All right. Maybe this is the best way to do it. I'll just give you an example. What if it was 8? Remember, that much is how much? What if it was, that's about 8. Do you make a triangle? What if I swing it in this way? Would it make a triangle? And what if I swing it out this way? I never told you how long this one was. So that would create, Kenzie? Yep, we're taking that side and we're swinging it to see if we can form a triangle. Right. Okay. So we'll go 8 right here. Could I put 8 right about there? Could that swing up this way? And could it also swing out this way? Because I never told you how long this one was. Could that keep going and make it 8 that way? Good. So I'll show you the 2 it could make. It could make that one right there. Right? You see that one? Or it could make that one right there. Right, it has to hit perfect. Yep. The question there is, does it have to go to the end of that line? And yes, it does. It has to hit perfect. There's only one more case. Can anybody think about it? And if you can, you've got this down real fast. Let's say like 12. Yeah, it could swing this way. But as it swings this way, isn't it going to be further than the 10? But what if it swings this way? Make one really big one, right? But it's only going to make one. So let's go through the situations and see if you can figure it out. Situation 2, the angle given is acute. Do you agree that my angle A in this picture is acute? And in fact, I think I have 42 in there for you, don't I? Go ahead, figure out B sine A right now. How big is that? Again, you take the angle and the non-paired side. How long is that side that would create a right triangle? 6.7, right? So how about that angle right there, this one that's 5? If I told you that was 5, look how that swings. Does that ever actually create a triangle with the 10 and the 42? That doesn't make a triangle, does it? It's not long enough. So how many answers does that particular problem have? None. Let's say you're going to like those, right? And the more no solutions you get, the quicker this is going to go.